Hello everyone, in this video we'll be solving problem 3456. Find special substring of length k. The problem statement is we are given a string s and an integer k. We need to return true if a substring exists based on the criteria given to us, or else return false. The criteria that are given to us are the substring contains only one distinct character. All of the characters in the substring should be the same. The character before the substring and after the substring should be different than the character within the substring. In example number 1, with k is equal to 3, there are two possibilities of substrings in the given S that are valid. Starting with the first three characters A, as there are no characters before A and the character after A is B, which is not equal. So this is a valid substring. There's one more substring in the string that is valid, which is at the end 3a's, as there are no characters after it and the character before it is b. As both of the substrings are valid, the output is true. In example number 2, there are no valid substrings with the size equal to k, hence the output is false. I hope you were able to understand the problem statement. Now let's switch to whiteboard and discuss how it can be solved. One way to solve this problem efficiently is using two pointers and the sliding window approach, where we'll use the first pointer to point at the starting index of the substring, while the second pointer will be pointing at the ending index. And during the traversal, if the criteria that are given to us are valid, we'll keep on expanding the window, and at any given point of time, if the criteria are not met, we'll calculate the length of the substring and compare it against k. One simple way to calculate the length of the substring is ending index minus starting index. And whatever is the value, we'll compare it against k. If the values are equal, we'll stop the iteration and return 2, or else we'll continue the iteration until the end. And if we do not encounter any valid substrings, then we'll return false. Let's do a couple of simulations using this approach to get a better understanding how will this help solve the problem. We'll use I pointer to point at the starting index, while j will be used for the ending index. Starting off with I and j is pointing at 0, we'll start with checking if both the starting index and the ending index value are the same. Because both are pointing at the same index, the value is going to be same, so we'll only increment the j pointer. That is to expand our sliding window. So for the next run, my I will stay as 0, while j will be incremented to 1. We'll do the check again to see the values. J is pointing at A, the value is still equal, so we'll only increment the j pointer to 2. Again, the value of I and j are equal, so we'll repeat the same cycle, increment only j. For this iteration, j is pointing at B, the values are not equal here, so we'll calculate the length of the substring and compare it against k. The formula is j minus I is it equal to k. As j is 3 and I is 0, the difference is 3, which is equal to k. As the values match and we have sufficed all of the conditions given to us, this is a valid substring. So we can stop the iteration here and return true. Let's assume that the condition is not met and k is actually set to 4. So when we encountered, so during the iteration, when we ran into B, so when j was pointing to B, the conditions were not sufficed as the length of the substring is 3 and we are looking for 4. So we'll start a new substring starting with the first character as B. So the value of I will be changed to the value that is j. So I is equals to j, and then we'll start a new window. After this update, the next iteration I will be 3 and j will be 4. The next iterations will be to verify if we can build a batch with B's in it. With this solution, our time complexity is O of n, where n is the size of the S string, and the space complexity is O of 1 or constant space. As we are not creating any additional collection for the calculation, we are simply using these two pointers to maintain the starting and the ending index of the sliding window or the substring. I hope you were able to understand this explanation. Let me show you how we can implement this using C#. Here is the C# solution. I start by initializing my first pointer I, setting it to 0, and then start a for loop for the second pointer. I first check if the value that I and j are pointing, are they equal? If yes, then I continue the for loop so that I can maximize the window size. If the condition is not met, that is the values are not equal, then I'm calculating the size of the substring or the sliding window. If the values match, then I'm stopping the iteration and returning true as we found our valid substring. If not, then I'm resetting the sliding window to start from j and then continue the iteration. There is a possibility that the substring which is valid is at the end of the string. To cover that case, we are adding another check after the for loop is complete. The check is the same where the ending index is actually the size of the array and the starting index is I. This code, when submitted on LeetCode, beats 100% of the submissions in terms of runtime and nearly 100% in terms of memory. Thank you for watching this video. I hope you were able to understand the explanation. The link to the code is available in the description below. Feel free to check that out and I will see you in the next one. Thank you.